Good morning, everybody. Today is Tuesday, August 16th, 2022. I am man drinking decaf coffee, and we're here to do some Elixir. I don't know. Yesterday was a weird day. I didn't really feel that good, and I was tired later in the day after doing some work, and it was one of those cases where it's like, well, I'll eat an early dinner, and then maybe I'll come back to work and see how I feel. And I did that, and after dinner I was still really tired, and then I went to bed, and then I couldn't fall asleep, which is the most frustrating thing in the world. So anyway, I don't know. Today, got up, made sure I did my exercise, and I'm going to drink some decaf and hopefully get back on schedule. But for us today, we are going to get into two new topics. I believe we're going to do maps and module attributes as constants. All right, now that my air filter has calmed down, let's get into it. First on the schedule is maps. So maps are a huge part of Elixir. Maps in Elixir are the data structure for storing information in key value pairs. In other languages, these might also be known as associative arrays, hashes, or dictionaries. Keys and values can be of any data type, but if the key is an atom, we can use a shorthand syntax. Maps do not guarantee the order of the entries when accessed or returned. Literal forms. An empty map is simply declared with a % and curly braces. If we want to add items to a map literal, we can use two forms. If the key is an atom, we can say atom key :1. If the key is a different type, like an integer, you can use the arrow token, which is $greater than. You can even mix these if the atom form comes second. Wow, that looks really weird. I don't think I'd ever see that in production code, but so be it. While there is no canonical format, choose a consistent way to represent the key value pair literal pairs. Map module function Elixir provides many functions for working with maps in the map module. Some map module functions require an anonymous function to be passed into the function to assist with the map transformation. And this is key because you're going to do a lot of transformations where you've got a map of a certain shape and you want to transform it into a map of a different shape. Similarly with lists, you'll see very similar stuff there. The thing I want to bring up talking about this is the atom key stuff. And this was something that took me a little while to get really comfortable with. So when we learned the atom lesson, of course we learned that atoms start with a colon, and then they have a alphanumeric with underscores allowed, value, body. And this is an atom, and an atom is basically kind of a strong symbol that you can use in your code, and during the runtime it's part of a lookup table, but for us as humans, we can read them and they look really nice. But when you talk about atom keys and maps, what's really, I think, confuses a lot of people is the fact that the colon goes on the right hand side of the term. So in this case, you've got atom underscore key, and then you've got the colon. But normally, if we were to talk about the atom atom underscore key, it would start with a colon, and that feels weird. And I don't really have any good logical way to explain why this is. It is what it is. It took me a little while to get used to it when I first started with Elixir. So if you feel a little uncomfortable with that, I think that's normal. But you will get used to it. All right, cool. And then the second concept that we're going to talk a little bit about today is module attributes as constants. So in Elixir, we can define module attributes, which can be used as constants in our functions. So here we've got a module called example, and we are going to define an attribute as the value 1. So we have an @, then the word constant number, and then a space, and then the integer value of 1. And then inside of example value, you can say, give me the value that was in constant number. When used to define module constants, Attributes can be any expression which can be evaluated at compilation time. After compilation, module attributes are not accessible since they are expanded during compilation, similar to defined macros in languages like C. And this is kind of an important thing to note. So like just because you have created a module attribute called constant number, it's not as if some outside module can then say example dot constant number and get the value 1. That doesn't make it like a publicly accessible value. It's just like internal. And so we often use module attributes for drawing up values, for configuration like things. They're very popular. You can put them anywhere, but it is preferred to have them at the top. I believe you can put them anywhere. That might be. I don't know if there's any rule there. Attributes can also be read inline functions. My data 14, my data 13. Yeah, so you can. This is redeclaring them. I wouldn't do that, but you can show it. It shows it. It is legal. Cool. And so with that, I believe we're going to be working on high score, right? So high score, in this example, you're implementing a way to keep track of the high scores for most popular games in your local arcade hall. Because, of course, we all hang out at the local arcade hall. All right, so we're going to download our example. And we're going to cd into that folder, and we'll open it in VS Code. And I'll maximize it, and we'll start by opening our library, opening our test file, move the test file over, and then we'll open up the README, keep that open on the third panel, and we will get started. So let's see here. So we're going to collapse the def modules so that way we can test stuff at cursor in clear visual way. All right, so we're going to start with number 1. Define a new high score map. To make a new high score map, define highscore.new \0 function, which doesn't take any arguments and returns a new empty map of high scores. So it's going to return. Okay, that should be easy. So when they call new, they're going to get an empty data structure, which is an empty map. What's this trivia? Trivia scored using this test suite are based on lines of code added to the GitHub project. Okay. So we're going to run test at cursor and verify that this works. That looks good. New is working. All right, number 2, add players to the high score map. To add a player to the high score map, define high score.add players, which is a function which takes 3 arguments. The first argument is the map of the scores. The second argument is the name of a player as a string. The third argument is the score as an integer. The argument is optional. Implement the third argument with a default value of 0. Store the default initial score in a module attribute. This will be needed again. Okay. Alrighty. So here's an example. So they're generating a new score map. Then they say add player, and they expect to get back a map with Dave Thomas. Another score map, Jose Valim, and then that'll be that. Okay. All right, cool. So we'll start by declaring a module attribute called default score, and we'll give that a value of 0. And then we'll say score will default to a default score. And then we've got our scores, incoming scores. So a lot of ways to do this. I'm going to bring up the map documentation. Oh, they don't do that. They do that. So kernel Elixir map. And we'll take a look at here. So this is the map. You got fetch for getting values. And then, yeah, this is when a key that does not exist in the map is updated, the key R will be raised. So, yeah, so this is the shorthand. This is something I do a lot. This isn't appropriate here because we are adding keys. We're not changing the value of a key. But, yeah. So this is probably what we want, where we want to say merges two maps into one. All keys in map 2 will be added to map 1, overriding any existing one. The keys in map 2 have precedent over the ones in 1. So I think that's kind of what we want for this this update. I mean, you can do like put as well. Let's see, puts the value in key on an inline by the compiler. And if you do, yeah, that'll just override. I will do put. I mean, it's a little tough to choose. So given the scores map, we'll put the name, and then we'll put the score and add players. We will test at cursor. Cool, that looks good. Add player seems to be working. So now we want to remove players from the score map. To remove a player from the high score map, define high score remove player, which takes two arguments. The first argument is the map scores. The second argument is the name of the player as a string. And remove player. Okay. So map dot drop is one maybe. Drops keys from map. I believe that's what we want. Just verify. This is all about education, so might as well just look. So yeah, so given a map with A, B, and C, drop B and D, and you'll just get that. That seems good. Scores. Game. Drop needs to be a list. So put that in a brackets. And now we will test a cursor. That looks good. Cool. This style, by the way, if you're just getting started with Elixir, where basically you've got a module and it has kind of like a data type, and then all of the functions of the module, or many of the functions of the module, basically the first argument is usually an instance of that instance. This is a bad word, but a value of that data type, and then it returns one. So like this add player here takes a map and returns a map, and so we're using a map as the data type. And that's a little loosey-goosey. As you get more sophisticated with Elixir, you probably do other ones, more structured data types. But all right, cool. So reset score. To reset a player's score, define high score, reset score, which takes two arguments. The first argument is the map of scores. The second argument is the name of the player as a string whose score you wish to reset. The function should also work if the player doesn't have a score. All right, that is key. So I believe this will just work. So default score. And we'll reset running cursor. Cool, that looks good. Then we'll have update score. To update a player's score by adding to the previous score, define update score, which takes three arguments. The first argument is the map of the scores. The second argument is the name of the player as a string whose score you wish to update. The third argument is the score that you wish to add to the stored high score. Ah, here we go. Now we're getting fancy. So let's do this. So we'll set up new score, and we'll do this as a separate one. So we'll say new score equals scores, and we want to access it. So we'll say name plus score. So that'll give you the current score, and then you'll add the new score. And let's see if that works. And it failed. It failed gloriously. Bad argument nil plus. Oh, there we go. So let's try using get. That way we can say the default. So get is a function that says like map.get. You provide the map. You provide the key. And you'll get back nil because there is no value for this. But if you use the third argument here, you can say what the default should be. And that is more appropriate to what we want. So rather than using the accessor, we will say map.get scores name, and the default will be 0. Actually, the default should be default score. So that way if we change it later, that should work. Alright, let's test update score, run at cursor. Cool, that looks good. Alrighty, next up, number 6, get a list of players. To get a list of players to find high score, to get players, which takes one argument. The first argument is the map of scores. And so you expect to get a list of the keys. That'll just probably be map.keys. Yeah. Scores. And we'll run a cursor. Cool. That looks good. Now we will test all in file, just so we can verify that all looks good. That looks good. Am I happy with this? Yes. We could add specs. Type specs is coming up in the syllabus, so I'm gonna wait until we do that. Once we do that, I should probably try to make sure I add type specs to all the functions. But because we haven't done type specs yet, I'm gonna avoid that for this example here. And let us submit lib. And we will open. So we got one robot complaint. Recommended use map.update score to update scores with a single call. Use map.update and update score for the update function to find an anonymous function using function. Okay. We can do that. So it wants us to use map.update existing value. Okay. Fine. Be that way. Let's see. So we've got our initial map. We've got our key. What is that? A13. Updates the key in map with the given function. If key is present in map, then the existing value is passed to function and its result used. If key is not present in map, default is inserted as the value of key. Okay. So this should be default. And then the function should be, I'm going to make this a little wider just so you can see what it looks like inline. So existing value plus new score. That looks good. And we could get rid of new score up here. We could just say get score. I'm going to leave it. Alright, let's rerun the test just to make sure everything still looks good. And it fails gloriously. Assert failed. Why did this fail? Plus score. Oh, I'm adding it twice here. Alright. Well, fine. We'll do it inline. Like once, like you want. Score is unused. Oh. See, now this is confusing me. So scores will come in. This is the current score. And then you need to add the new one. Okay. I'm going to call this new score just because I feel like I want to differentiate the existing value. And I'll even call that score. The existing score plus the new score. And that should be good. Got one more failure. So given, so this failed. What did this fail? So generate a new score. So there's nothing there. Update. Why does this not get that value? Updates the key in map with given function. If key is present in map, then the existing value is passed. Key is present in map. Existing value is passed to function. If key is not present in map, default is inserted as the value of key. The default value will be not passed through the update function. Okay. So we're saying take the scores map, update whatever name was. If there was no name, just put in default score. Oh. I think that would just be new score. Yeah. Otherwise, take the existing score, add it to yeah, that looks better. Cool. That looks good. Alright, let's try this out. You can quickly search through your sessions with view. Okay. Elixir submit. We've got our second iteration up, I bet. Iteration 2 looks good. It has passed. We'll sneak a peek at some of the community solutions. See if there's anything else that looks interesting. It's pretty standard. Let's see. Add player. Yeah, they used a anonymous, like an inline anonymous function. Which probably reads better for some people. I don't know. I think I talked about that before. That is not something that I always kind of like instantly grok when I read it. A lot of one-liner here. Yeah. That looks good. Initial score. Initial score is probably a better word than default. Starting score. Starting score is good. Cool. I think that looks good. Alrighty. So with that, we will mark our stuff as complete. We will publish our solution. And we have learned 2 new concepts, map and module attributes as constants. We've unlocked 3 new concepts, docs, IO, and type spec. There you go, type specs. And we've unlocked 5 new exercises. Alrighty. So we are just working through the learning exercises. And just as a point of reference here, the way this works, I believe, is so a lot of these concepts each have a learning exercise, and that is to kind of introduce you to the core, concept and how it works. And then they all have after, like I think the intent is that you would go through the map, probably focusing on the learning exercises to unlock different concepts. And then as you want, you can go through and do the practice exercises on those concepts. And each one of those have different levels of kind of difficulty, currently marked like easy, medium, or hard. And there was actually a discussion internally the other day about if easy, medium, and hard is a good terminology to use. And there were some other ones that I thought were better, like beginner, moderate, and advanced or something, because it feels bad to be like, well, I'm stuck on this example and it's an easy example. Like, it doesn't really. Easy is a curious adjective for that kind of stuff. But anyway, so the way this is going to continue to work is we're going to continue to work through these learning exercises, and then after we get through the concepts, we'll come back and we'll start doing some of the learning exercises. The practice exercises, which should get more interesting. But my general plan is to continue working on these about once a day, and maybe 2 a day, and maybe, I don't know. We'll see how that goes. But I want to have steady progress here, and yeah, hopefully you guys enjoy it. Thanks a lot for watching, and yeah, we'll see you next time.